Hi everyone. Hi. Hello. So yes, guys. Good evening, good afternoon, and good morning, everyone that has joined us from around the globe. Today we have a Jimmy from the Nodereal, and I'm your host from the BNB Smart Chain site, Rumil Hussain. Today our topic for the MA is the anatomy of the BNB Smart Chain. So hand over to Jimmy. Yes, please. You can. Jimmy will introduce himself. Okay. We after that he has some presentation deck. Jimmy will tell us deeply about the parallel EVM side. Okay. Let after that we will go for the Q&A side that the audience and the developers that we have. Yes, please, Jimmy. You can start.
Yeah, thank you, Romeo. I feel really honored and pleasant to be here, to be
Sure.
invited to join these exciting sessions. Actually, I'm Jimmy. I'm from Nodereal, and I'm the solution architect of the Nodereal. So my responsibility is to make sure we are delivering the correct product and for our customers, and make sure we follow our roadmaps and being the technical bridge from the external facing customers and to our product engineering team. So yeah, that's it. So today I'm gonna to do a very brief introduction about what Nodereal has been contributed to the ecosystem of the BNB Smart Chain. So actually, for those who are maybe you are not familiar with Nodereal, actually maybe I can do a very brief introduction of Nodereal first. So Nodereal is a one-stop solution, the technical blockchain technical solutions for the BNB chain and other chains as well. So we are also the core contributor to the BNB Smart Chain. So today I will talk about how we have introduced into the BNB Smart Chain. I mean the optimization to make our BNB Smart Chain ready for the mass adoption and to handle a lot of have a better performance and the uh, uh, quicker latency from the chain perspective. So before we start, let's go back a little bit about the history. You can see in this diagram, actually Ethereum was launched in 2015. It is a June 30th of 2015. And in the blue line, you can see here our BNB Smart Chain actually launched in August 2020, and the transaction traffic increased very fast, and we surpassed the Ethereum very quick. And in the 2021, we hit our highest transactions per second, which is about 188 transactions per second. So that means we have more customers, we have more active users and transactions. And EVM is always around 15 transactions per second for many years already. So of course, both the Ethereum and the BSC is not running in its full capability. So that means actually the BSC, the full capacity at this moment, in theory, can reach to 1,000 transactions per second. So according to our load testing. And our target will be around 5,000 to make sure we can have a better performance and have the better throughput and a stable blockchain. So as we all know that the blockchain, I mean the BSC, every 3 seconds there's a new block mined. So in this diagram, I will do a very brief introduction about how the process is like. First, I think that we need to download the block. After the download, I think the first thing is do a very quick header field checking to make sure the block is fine. And it's very fast, about a few milliseconds. And then after that, the will executing the transactions one by one in this block. And depending on the transaction size and the workload, it ranges from a range about I think the average is around 50 milliseconds to a couple of hundreds of milliseconds. So when all the transactions are executed, it will calculate the and update the MPT. This is this to make the world state consistent. To calculate the state root hash, it may take longer time. So it's around 50 milliseconds to hundreds of milliseconds as well. And even more, in some extreme cases, it can reach even more 1 second. And after that, the updated state will be committed to the DB, if it is valid, of course. And it's around about 100 milliseconds. And then it will commit transactions, get runnable transactions from the transaction memory pool and execute the transactions. And then finalized stage is similar to the validation phase during the block import. And then the sign phase is fast. Encryption operations will be executed and sealing the block with the miner's key. And it takes several milliseconds, should be enough. And if the time is within these 3 seconds, if the time is enough, the node may wait for very short time and then commit to the blockchain. So we define the whole process into these stages. So in here, we have 4 stages. One is the TD, which means the block download, and TI, which means block import. And this mining actually is kind of the execute, finalize, and commit, and the broadcast. So the whole process is just like that. Right, so every steps must be finished within 3 seconds. It's quite high requirements, actually. So we want to make sure to improve the node performance to make sure the blockchain itself is stable, so that all the operations can be finished within 3 seconds. So where the bottleneck comes from our testing data, you can see here, the bottleneck always coming from EVM execution and validation. So both of them can reach to hundreds of milliseconds, even to 1 second. So all the operation must be finished within 3 seconds. If one step takes a long time, so that means the blockchain maybe not that stable. So that's the target we want to solve and the problem we want to solve. So before we dive in, I'd like to introduce more about the cache layers. From the this is of course is a very high level diagram. So you can see here the smart contract have some kind of operation. The first will go to the cache, and then we'll go to the level DB. It is to have some IO disk IO operations. So if you look into the cache itself, actually it has 3 layers. The first layer is a hash map. The hash map holds the states that is accessed by about the current block. And the second layer we call the diff layer, which means hold the states that were updated in the past a few blocks. By default, it will be around 128 blocks. And the faster cache actually hold the even older states that were already flushed into the disk. So with the cache, we can increase the speed of the operation on the node, on the full node or validator node. So this is three layers of the cache mechanism. So if we want to improve the performance of the node, we want to, I think if you are familiar with the cache mechanism, I think the first thing we want to do is increase the hit rate so that the data access can be done in the cache layer without doing the disk IO. So this is our kind of the calculation, and according to our the load testing. So you can see here, the cache rate in the different layers around about 63 to 77. It depends on how long your node is running. After a while, the cache rate can reach to around 78 or 77. That is number. So yeah, so that's our testing data. So we want to increase the hit rate even further. So how do we do it? Actually, we have 2 prefetchers. Prefetcher actually is a separate process running in the background to prefetch the data to update the cache. So the first type of the prefetcher is try prefetcher. Actually, it's just load the data from the MPT and save the data into the diff layer and disk layer. Another kind of the prefetcher, we call it the transaction prefetcher. It is uh, the prefetcher that executed transactions to load data from a disk and drop the data from the memory. So let's go into even deeper into how the two kind of the prefetcher works. Actually, the try prefetcher works at the time when we execute the transactions, and it updates the snapshot data. And the transaction prefetcher actually executed in the commit the validation process. Just I mentioned earlier, the bottleneck comes from the transaction execution and the commitment. So with the shared mem pool, these two, the prefetcher actually um, prefetch the threads that share the data with the main thread, right? So we just grab the data and put into part of the layer 1.5 shared pool. So the data will be gathered from the disk and saved into the layer 1.5 to increase the cache hit rate from around 70% to 99%. By this way, the prefetched items can be directly loaded from the 1.5 layer cache instead of reaching to the diff layer and faster cache. So by doing this, you can see here, we started the block process, the mining process. We started the prefetch thread in the backend, and the blocking process mining time can be reduced. So that means the mining time the whole mining time can be reduced as well. So this is what we did, the testing before we introduced the prefetcher to increase the hit rate of cache, and after we can get around 44% the performance improvement. So you can see here, before the optimization, the block processing time is around 150 milliseconds, and after that is around 100 milliseconds. So it is actually it's a big improvement, to be honest. Okay, so another optimization actually we introduced to the BNB Smart Chain is that we call it the smooth validation. So the smooth validation actually is the problem we want to solve is when there is a traffic spike, the blocking processing time can be very heavily impacted, especially in the peak hour or peak time. So it impacted the stability of the blockchain very much. So we want to make sure we can handle the spike and to reduce the average block processing time by some the concurrency capability. So from this diagram, you can see here, the line in the blue area, it actually is before the smooth validation was introduced. So when there is a traffic spike, you can see here, the blocking processing time increases very fast. And the orange one actually is after the smooth validation was introduced. The block processing time is always stable, even in the spike time. The performance and the stability has been improved. So how do we do it? Actually, we add a kind of a concept called a sub prefetch for each addresses. So it is part of the tree prefetch, try prefetch. So for each addresses on MPT, we just created the sub prefetch process to fetch the data in parallel. to make sure we can increase the the capability of the node. So you can see here, this is a map for each account. For example, the account A, account B, and even to account X. For each account, we have the sub-prefetcher, and the sub-prefetcher will, the load the MPT into the snapshot to in parallel to save the time. And at the same time, the node can processing the transactions using the snapshot data. And this is, the monitoring, the BSC parallel monitor. You can see here, after the smooth validation is introduced, this is the red one. The average processing time is around 40 milliseconds, and it's always stable, even in the spike time. There's another optimization we have introduced for the BNB Smart Chain. Actually, it is called the block process pipeline. Pipeline is not a new concept. Actually, it's a traditional concept of the computer science. So it breaks the whole process into smaller pieces, and we can introduce kind of the concurrency to process each smaller steps in concurrent way. So of course, if you are familiar with the CPU architecture, in the CPU hardware design, it also have the pipeline to to handle the operations in the pipeline. So our technology is very similar to this design. So in this diagram, you can see here, for each block processing, we have the block process and the commit snapshot and state verification and commit and wait time. So for the block one, you can see here, we started the block process here and do the verification. But the verification does not need to wait for the commit snapshot, right? So the verification and snapshot can be executed in parallel. But the block for the second block, we have to wait for the first commit to be finished until to start the block process after this. But the commit and the process can run in parallel, and the verification has to wait for the first verification finish and then start the second verification. So if we break the processing process into smaller pieces like this, we can have the 4 different blocks have kind of the parallel, so it can increase the blocking processing time even further. For the snapshot MPT commit, we only, another thing I would like to mention is that for the snapshot MPT commit, we only persist the bottom diff layer to the disk, so that we don't have to worry about, we wait the verification to finish, and we call it is kind of the synchronized snapshot MPT commit solution. So this is a diagram if we look into the process, the block process pipeline. On the left hand, it is the traditional way we handle a block. On the right hand, it is something we introduced the block process pipeline. So if in the traditional one, we have to handle one step by step in the in sequence, but in the right hand, we can handle the in parallel. So I think the concept is very similar described in the previous page. Okay, and this is what we have achieved. It is the block process pipeline, and you can see here the green one, actually the processing time is around 73 milliseconds. After that, it can reduce even further to 24 milliseconds. So it is even 100% increase. The performance increase. Yeah, another topic I would like to cover is about the parallel EVM 2.0. Actually, with the parallel EVM, we introduced the dispatcher here. Through the dispatcher, we can have the concurrency capability. So the dispatcher will read the transactions and hand over to the transaction execution engine in the backend. So of course, the number of the concurrency can be configured according to the, it's kind of the trade-off. It's not always the bigger the better. It's not the case. So we want to have a better performance, and by default, I think it's 4. Or so if the dispatcher will handle the transactions, the transaction execution engine will handle it, and there is a conflict detection mechanism in the validation state. If there's a conflict, for example, if two people sending the transactions with the same account, for in this case, the conflict detection will find the problem, and some of the transactions will be re-executed before committed to the database. So it is kind of the, after conflict detection, before we do the transactions, and after we do the transaction. Of course, in the dispatcher, we also introduced a concept, kind of the transaction simulation, to even further to reduce the possibility of the conflict transactions. So in this two mechanism, we want to make sure the parallel can be maximized, and the transaction times can be reduced even further. At this moment, in the 2.0, the parallel EVM is only for the full node at this moment. And I will introduce a little bit after, because we are trying to bring the validator node to the parallel capabilities as well. So yeah, this is a table what we want to do in the future, actually. Besides the the optimization we have introduced earlier, we have more and more coming features that will be introduced for the BNB Smart Chain. I think first is the parallel EVM 3.0, which means we want, again, besides the full node, we want to start supporting the parallel EVM in the validator node. So this one has been in progress, and we are in the design phase and have started some work on that. And another thing I would like to mention is the network stability enhancement. For the network stability, there are some unstable factors. For example, the unstable network and validators go offline and traffic spike, etc. So we want to reduce the risk to increase the network stability. And this one actually is also in discussion and in design phase already. And some of the work has been started. For example, the smooth validation is one part of it. And also, another thing we want to improve is that at this moment, the revenue is distributed to the validators. We want to have more accurate, according to the validator's contribution, to make the reward distribution more fair for the validators. So this is still in design, and I will update the roadmap later once it is we have a clear picture. And of course, the last one is the validator order reshuffle. It is because right now the validator's order is fixed and predictable. I don't think it is good. So it would be better to, we can introduce kind of the on-chain random capabilities to shuffle the validator's order. Of course, this is also in design, and we will, contribute from this perspective into the BNB Smart Chain ecosystem. In the last, I would introduce what we have, provide from our product perspective. Actually, Nodereal is, again, one-stop solution. So we have the toolings like the Explorer, the App Stores, the NFT Marketplace, and we also provide the data indexing and query services. And of course, the NFT enhanced APIs like NFT aggregation API, DeFi API, or account and balance API, etc. And we also provide the privacy transaction capabilities with our direct route. So this is something we have served to the community and the developers as well. For the core infra and the services, of course, we have contributed to to the BNB Smart Chain optimization just I introduced. Besides that, we are also the core contributor to the ZK BNB and the BNB application chain as well. Yep. Yeah, that's it. Rumil, that's all the optimization we have done.
Awesome, awesome. Thank you for sharing your insights on the parallel and the concurrency side, parallel EVM side. So let's move to the question side. I have a question that uh, is there any progress of parallel EVM on Ethereum side?
For the Ethereum, I don't think so, because from my perspective, I don't think Ethereum has the requirement. Because as we always say, the Ethereum is always 15 transactions per second. So it's
Agree.
not that like BNB Smart Chain we have a huge active users, and the Ethereum at this moment the traffic requirement is not that high. And besides that reason, I think the Ethereum is working on the Shanghai upgrade recently, and of course after that they may put more efforts into the sharding solution. So
Hmm.
I don't think the Ethereum has this kind of the feature ready.
So do you think that Ethereum can apply these performance patches?
Yes, of course, because this kind of the optimization actually is based on the EVM,
Hmm.
code base actually, because the BNB Smart Chain is also the EVM compatible. So this optimization can also be applied to Ethereum. So in the future, if the Ethereum ecosystem is booming and have more and more active users and real cases, so we may contribute our code to the Ethereum ecosystem as well. I think we can make the ecosystem better together.
Cool, cool, cool. So as we are open source, so we have to
Yes,
contribute it. Yes.
yeah, we are open
So
source
I
and we are open and we are feel honored to be contribute our efforts to the ecosystem, the open source community.
sure, sure.
Yeah.
So I have an other question is there any performance target of BNB chain? How fast will it be enough? It will be
You mean the transaction per second perspective?
transactions per, yeah, TPS.
Yes, I think the current transaction per second, transaction per second is depends on how the transaction looks like, right?
Hmm.
So it has some factors can impact it. But according to our testing data, our current BSC transaction per second reached to 1,000. So um, I know that our BSC is now running in the full capacity because at this moment the market is not that good, especially what happened recently. So the real transactions per second on the chain actually is around 100 transactions per second at this moment, and for the Ethereum is about 10, right? So in theory we can reach to 1,000 with the fully optimized BSC smart chain.
Cool. So right now the TPS on the BNB Smart Chain is the 120 million, right? So what you will be think that the gas one. So gas is the
Um,
120 million.
I
So
think
what will
it's
you think? How it will be increased
I think it would be 300 million gas limit after the
gas limit
optimization in theory.
after
Yes.
the
It's,
optimizations? Okay.
yeah, yeah. I think
So
it's much better than Ethereum.
so it will be double, 2x, more than 2x.
Yes, yes, more than that.
Okay. So the it was my last question. So before moving ahead, conclusion side. So I just want to share with our audience that this code for the Nodereal one is open source and is available on uh, Nodereal repo of the BSC release version 1.1.16. If you want to try it, you want to check it, you can download it and run it. But please be aware of that only full sync mode is supported. Validator mode is not supported right now. Second thing, only the BNB chain is supported right now. Generally, if you want to use this with Ethereum, okay, it has not been fully tested actually. So it could be broken or you will face some errors. So before concluded the AMA, Jimmy, do you have to say something more?
Yeah. So if you try to test out the optimization from our Git repo, you can go to the
Mm.
Nodereal Git repo to have the code, and you can follow our Twitter and Discord. If you encounter any problems, I'm very happy to reach out to help you to start your testing.
Yeah, cool. So let's thank you community that you guys have joined. If you have any questions or more questions that you want to that we should be answered, you can ask to our on Discord channel. Okay, invite/BNB chain. You can ask the questions there, or you can raise the question on the GitHub side. So we are happy to answer all your questions. So see you in the next call and the next AMA with some new innovations things. Thank you. Bye bye.